Hi everybody, welcome to another video in Pre-Calculus section 5.5. Now, we define trigonometric function using a unit circle approach. So, now, let t be a real number and let a point xy be the point on the unit circle. Now, in the new unit circle, meaning that x squared plus y squared is equal to 1. And earlier we defined r is equal to square root of x squared plus y squared, which is also equal to 1. So the radius, the distance r is equal to 1. So then the definition, we have y over r is sine t, y over r, or y over 1, x over r, or x over 1. So pretty much now, since r equal to 1, we can write the definition is equal to that. Because earlier definition we say sine is y over r. Now if r equal to 1, we just have y. Cosine is x over r. Now if r equal to 1, then we just have x. So that's what we have here, definition. Now, of course, y over x for tangent and still the same. Right. Notice that every time we have the definition as a fraction, make sure that the denominator not equal to 0. Denominator not equal to 0 for all of that. Now, find sine t, cosine t if the point is equal to that point. Now it will be easy, right? We have sine of t is equal to y, which equal to negative 1/2, and cosine of t, which equal to x, is negative square root of 3 over 2. So it's no big deal. So what is the big deal here? So why we define on a unit circle, right? And then earlier, why do we use theta for the central angle, right? Now, if the point is on the unit circle, then what we use is sine of t. So what is t here? T will be the length of this one. So we have the arc length formula. The length of an arc is equal to the radius times the central angle. But this time the radius is equal to 1. So the arc length here will be the same as the measure of the angle in radian. So that's why now we define a trigonometric function not for a central angle, but for the arc length on the unit circle. So that's why we switch the variable from theta to t. It is defined on an arc length on the unit circle. And that's exactly what we do here. The arc length. So if the angle is equal to the arc length in radians, then the trigonometric function of theta is the same thing as trigonometric function of t. So the trig function for the central angle is the same as the trig function for the arc length on the unit circle. That's exactly what we have here. So, and then if we have a bigger circle or smaller circle where the radius is no longer 1, then of course we have sine is y over r, x over r for cosine, y over x for tangent. Flip the sine, flip the cosine, and the tangent. So that's what we had before. In this case, r could be anything. Right. Now, I'll find the exact values for 6 trigonometric function for this one. Of course, we did this before, right? X is negative 3. Y is equal to 4. So r is equal to square root of x squared plus y squared. square root of 25, which is 5. We have x, y, and r. Then we have on the trig function sine is equal to y over r, cosine x over r, and tangent y over x. And then reciprocal function cosecant, flip, secant, reciprocal of cosine, and cotangent, reciprocal of tangent. Right. Now, remember, trigonometric function of a central angle is the same as the trigonometric function of the arc length on the unit circle. Has to be on the unit circle. Now, the reason we need that, so we will have the domain and range of this function. So let's look at the domain and range. The domain of sine and cosine. So doesn't matter where the point is on the unit circle. Doesn't matter where the arc length is on the unit circle. There's always an x coordinate and y coordinate, right? So in this case, the domain of sine, cosine will be negative infinity to infinity. Why? Because sine is equal to y, cosine is equal to x. Doesn't matter where the point is, x and y is always defined, right? So because sine theta is equal to y, cosine of theta equal to x. If we're talking about unit circle, right? So r is equal to 1. So because of that, it is defined everywhere. It is defined for every t, or every theta. Right. So now we refer to the unit circle only. Right. Next we have cosecant and cotangent. What is cosecant and cotangent? What do they have in common? Divide by y, right? So let's write out cosecant. If it is on the unit circle, cosecant is what? 1 over y, and cotangent x over y. If it is on the unit circle, because of that, the domain of this is where y not equal to 0. So where's y not equal to 0? We're talking about this point, right? This is where y equal to 0. So meaning that we cannot have pi. Meaning that theta cannot equal to multiple pi. Cannot equal to 0, a pi, 2 pi, 3 pi, 4 pi, and so on. So cannot be a multiple of pi, because we have the cosecant and cotangent is 1 over y and x over y respectively. Y cannot equal to 0, so we cannot have those points. Next, secant and tangent. What do they have in common? Secant is 1 over x, and tangent is y over x. Secant is 1 over x, tangent is y over x. The domain is where x cannot equal to 0. meaning that x cannot equal to 0, so we cannot have this point, meaning that theta cannot be equal to pi over 2, which is here, 3 pi over 2, 5 pi over 2, 7 pi over 2, and just keep going like that. So we theta cannot be equal to pi over 2 plus k pi. Right. So the domain of sine, cosine, all real numbers. Domain of cosecant and cotangent, everything except for multiple pi's. Domain of secant and tangent, everything except for pi over 2 plus k pi, except those 2 points. Right. Now, so if we just that is the unit circle. Now, the range. Now, the range, if it is on the unit circle, x and y can only be from negative 1 to 1. Because it has to be on the unit circle, right? On the unit circle is equal to 1. Because x, y is in the unit circle. In the unit circle, x can only go from negative 1 to 1, and y can only go from negative 1 to 1. Therefore, sine, cosine can only go from negative 1 to 1. Now, cosecant, secant, and tangent and cotangent will be different. All right, now, so if we have the unit circle, and then we will draw the tangent line, in that case, this is called the tangent axis. For example, if we draw a line like this distance here is tangent of theta. And if we want to write cotangent, we draw this axis, the tangent line to the circle at this point. Right. Why is that? Well, this is 1, this is theta. We write tangent of theta is equal to whatever this is over 1. So x is equal to tangent of theta. So that's why we have tangent of theta is that length, which is the tangent line to the unit circle. And that's why we define that ratio to be tangent, because that is from the tangent line to the unit circle. So that is tangent. Now, if it is on the unit circle, you can see that it doesn't matter where the angle is. It will intercept a point on the line. If the line goes here, then this will be tangent. So pretty much tangent values can take any, it could be any point on the line, and the distance, so it can take any values on the tangent line. So because of that, the domain of tangent and cotangent is all real numbers, or all real numbers. Yeah, because if we have that angle, then we have the tangent value to be this much. So whatever it is, intercept on the tangent line. Therefore, we define tangent. And cotangent, we define that to be this tangent line, horizontal tangent line. Right. Now, secant and cosecant. Now, if this is tangent, we have 1 square plus tangent square is equal to secant square. So this is going to be secant of theta, or the unit circle. Now, and secant in the Greek in Greek means cut. Tangent means touch. So we touch the circle here, get the tangent, and if we cut the circle, we have secant. So that's why they name it that way. Now secant, notice that it doesn't matter where the point is. The length of the secant will have to be a point at least on the outside of the circle. The best case scenario will be right here, where secant is equal to 1. But other than that, if we have a point on the tangent line here, connect to the center, it is always bigger than 1. If it's down here, it will be bigger than negative, smaller than negative 1. So, in that case, the range will be negative infinity to 1 to negative 1, or from 1 to infinity. So it can be anything but 1. Anything but between negative 1 to 1. Because that is always outside of the circle. This distance must be greater than 1. If it's down here, that will be negative. Sorry, I mean, this one is still positive, but it is on this side, it will not intersect, but we have to extend on the other side, and if it is over here, it will be negative. Sorry, but the magnitude have to be bigger than 1. The point have to be outside of the circle, therefore it's bigger than 1, right? So that's the way we define on the unit circle, give us the domain and range of the trigonometric function. Right. Tangent can be anywhere on the line, therefore all real numbers. Secant have to be bigger outside of the unit circle, therefore it have to be bigger than 1, of course, or less than negative 1. Less than or equal to negative 1. Right. Periodic function. A function is called periodic if there's a positive number p such that whenever theta is in the domain, theta plus p is also in the domain, and f of theta plus p is equal to f of theta. Pretty much the y values will repeat itself. And for the smallest number p, we call that is the fundamental p, or just the period of the function. Right. Now, what is the period of sine? Now, if we just go around the circle and get back to the same point, x and y will be the same. Therefore, the sine cosine will be the same if we go one complete revolution all around. So the period of sine cosine is 2 pi, because sine of 2 pi is equal to sine of pi. Sine theta plus 2 pi is equal to sine theta, and cosine theta plus 2 pi is cosine of theta. Because when we go one complete revolution, if we get back to the same point, if we have the same x, y, we have the same cosine and sine. Similarly, the reciprocal function, the period is also 2 pi. As long as we have the same point, we have the same x, the same y, we'll have the same cosine and sine. If we can go extra revolution or not, still the same thing. Right. Tangent and cotangent will be different, because if we have the point xy there and the point negative x, negative y there, these 2 points though, tangent is equal to y over x, which is also equal to negative y over negative x. Negative, negative cancel out. So this point y and x and y and negative x, negative y will have the same tangent values. So in that case, we say the period of tangent is a pi, cotangent same thing. So tangent, cotangent, the periods are pi, everything else are 2 pi. So how did that help? By the way, Here we use 2 pi, but of course 2 pi is equal to 360 degrees, and the pi is equal to 180 degrees. Now with that, we'll find the values for some function here. Sine of that, of course, if we add 2 pi, it's the same thing as subtract 2 pi. That's what we can, because the period is 2 pi. What is 765? 765 minus 360. Yeah, the reason is that too big of a number, so I try to bring this into within a number between 0 and 360. That's still too big. We can also subtract 360. So when we add 360 or minus 360 to a sine, cosine, secant, cosecant, these 4 functions, the values will be the same. That will be 45 degrees. Back to this, 45 degrees. Sine is number of fingers on the right, square root of 2 over 2. Right. Nice enough. Next, tangent of 25 pi over 4. Well, that seems like too much. So let's subtract 2 pi. So it's 25 over 4. Oh, that's 6.25. So not only we can subtract 2 pi, we can subtract multiple of 2 pi. So let's say 3 times 2 pi. Will still be the same. Subtract the multiple of 2 pi. So that gives us 6 pi, and so we have tangent of pi over 4. Right? So we can subtract 2 pi, but we, rather than doing this many times, we just say subtract 3 times 2 pi. And tangent of pi over 4, tangent will be square root of the number of fingers on the right divided by square root of the number of fingers on the left. So we have 2 over square root of 2, which is 1. Next, cosine of 11 pi over 3. What is 11 pi over 3? Right, so 3.6667. Right, so we can say we have that minus 2 pi. It will get to the same values because period of sine, cosine are 2 pi. We can just subtract 2 pi to get the same values. If it's too big, subtract 2 pi. If it's too small, add 2 pi. Can always do that. So what do we have here? Of course, we take that, subtract 2. And convert to fraction, 5/3. Right, so where's 5 pi over 3? Well, here we have 0, here we have a pi, here pi over 2, or we say 0.5 pi, and here we have 1.5 pi. So 5 pi over 3, 5 over 3 is 1.667. So it's about here. In quadrant 4. Right? 0, half a pi, 1.5 pi. 5 over 3 is 1.667, so it's more than 1.5. So in that quadrant, cosine is positive. Right? Own, store, take cash. So this quadrant, cosine is positive. Besides, cosine is equal to x over r. x in this quadrant is positive, so it's positive. And then we can just say it using the reference angle. We did this in the previous section. It will be plus or minus cosine of the reference angle of 5 pi over 3 will be just pi over 3. Remember, both of them divide by 3, right? Or I can say it in general, if I can just say cosine of 100 pi over 3 will be plus or minus cosine of pi over 3. If this divided by 5, if this divided by 6, how about, okay, cosine of 100 pi divided by 3 will be pi over 3 because both of them divisible by 3. Both of them have 3 at the bottom. Now, how about cosine of 100 pi divided by 6? Before we do that, have to reduce cosine of 550 pi over 3, right? Have to reduce it first. If it is a reduced fraction, then cosine of this, the reference angle, will be pi over 3. So, reduce the fraction first, leave the pi out, reduce the fraction, whatever number at the bottom. If it is 3, 4, 6, or 2, then we have pi over that number is a reference angle. So reference angle here is pi over 3. And this is going to be positive because of in the 4th quadrant. So cosine pi over 3, number of fingers on the left will be 1 over square root of 1 over 2, or just 1/2. Right. If you use a calculator, make sure that it's in the radian mode, and cosine of 11 pi. Yeah. Right. So remember what we did previous section. We find the reference angle and we do the trig function for that reference angle. The plus or minus sign will be determined by the quadrant. And that's exactly what we do here. Right, try something else. Next we have even and odd properties. So note that an even function f of negative x equal to f of x. An odd function is f of negative x equal to negative f of x. And all of the trig function, cosine, secant are even, everything else is odd. So note cosine of x and secant x are even, everything else every other trig function is odd. So how did that help? Well, it helped because sine is an odd function. So if we have sine of a negative, it's a negative sign. Right? So that is an even and odd properties. Sine is an odd function. So sine of a negative is a negative of a sine. So sine of 30 degrees, all right, one finger on the right, square root of 1 over 2, so just 1/2. Okay. If you use the calculator, make sure it is in the degree mode before we do the trig function. Right, negative 1/2. Next, what is cotangent of negative 5 pi over 4? First, cotangent is an odd function. It is not cosine or secant. So this is equal to negative cotangent of 5 pi over 4. That's the first thing we can do, right? So the negative here because cotangent is odd. Next, we can do this. We can find the reference angle, but I can do one better. Why can we say that? First of all, 5 pi over 4, 5 over 4 is 1.25. So it is within 0 and 2 pi. So I will not subtract the interval. Of course, I can find a reference angle. But with the plus or minus, that could be a problem. So let's just instead do that. Why can I write like this? Simply because period of cotangent is a pi. So if we subtract a pi to it, the values will not change for sine, for tangent and cotangent. Five over 4 minus 1 is 0.25, so which is just pi over 4. Nice enough, right? So we have negative. Our cotangent is 1 over tangent. And pi over 4, tangent is square root of number of finger on the right divided by square root of the number of finger on the left. Square of 2 over square root of 2 is 1. So tangent of pi over 4 is 1. Right? So that's what we can do. Use the odd and even function, take care of the negative inside, and we can add 2 pi in or subtract 2 pi if it is sine, cosine, secant, and cotangent, because cosine, sine, secant, and cosecant, because those 4 functions, the period is 2 pi. Tangent and cotangent, the period is 1 pi, so we can just subtract or add a pi to it, the values will be unchanged. Right. Of course, we can always use the reference angle and the quadrant like we did in the previous section. But what I do here is we use what we have in this section, namely the period and even and odd. If we use even and odd, cosecant, again, is not even. So cosecant is odd. So it is equal to negative cosecant of 5 pi over 3. What is 5 pi over 3? 5 over 3 is 1.66. So it's still within 0 and 2 pi. Right. Now, we do that because cosecant is odd. Right. Next, what is the period of cosecant? Sine, cosine, secant, cosecant, the period is 2 pi. So we can just subtract 2 pi. Or we can add 2 pi to it. The reason I want to subtract 2 pi, because get to a very small number. So this is equal to negative cosecant of negative, change that to fraction, pi over 3. It's nice, right? Next, once again, cosecant of a negative is negative of cosecant, so we have negative of a negative cosecant of pi over 3, or we have cosecant of pi over 3. Right, cosecant is odd, so we can take the negative outside, and the period for cosecant is 2 pi. We can subtract 2 pi. The reason I subtract 2 pi because 5 pi over 3 is very close to 2 pi. If we subtract each other, we have a very small angles, and of course that angle is within 0 and 2 pi, which is within 0 and pi over 2, so we can easily find the values. Cosecant is 1 over sine. Pi over 3, and sine is the number of fingers on the right, that's square root divided by 2. So it is 2 equal 2 over square root of 3. Right, so this exercise we use 2 things. period, and then even an odd function, take advantage of that. Cotangent is odd, so take the negative outside. If it is even, we just take the negative away. But this is odd, so negative will go to the outside. If it is even, the negative will disappear. Take it out. Alright, and then the reason we subtract 2 pi here, because if we add 2 pi, that would be too much. If we subtract 2 pi, so try to bring that into a smaller angle, but happen to be negative, which is fine though, because cosecant is still an odd function, so take the negative outside, 2 negative on the outside, turn to positive. And cosecant is 1 over sine, and that's what we have. Right, so that's all I want to cover in this section. So I stop the video here. As always, thank you for watching, and see you in another video in pre-calculus.